Thank you everybody for joining us and welcome to the USC Viterbi School of Engineering Admission Faculty Roundtable. My name is Paul Ledesma. I am the Director of Undergraduate Admission at the USC Viterbi School of Engineering. Today we're doing our faculty roundtable with faculty from the Computer Science Department. And so we have a number of people joining us. We have a large group in our webinar. So there's a number of you in our Zoom webinar right now. Hello to all of you. We're also simulcasting live on YouTube, and you all have been a chatty group. I can see you all out there asking all your questions. What I'd like you to do is sit tight for the time being and watch for a little bit. Let's settle down on the questions for a little bit over there on the YouTube channel. What we're going to do first is we're going to have all of our faculty introduce themselves, then we're going to dive into the questions. The ground rules for today are, I'd like you to kind of sit through and understand a little bit more about our faculty and about our department, about the academic disciplines in computer science at the USC Viterbi School of Engineering. I'm going to have some questions that I'm going to be hosting and kind of letting the faculty know, and we're going to be chatting about this all together. And then towards the latter half of the session, I'm going to open it up to Q&A. And at that point, you all can start asking your questions. As you start asking your questions, when I allow that time to happen, then we'll start moderating and we'll get to as many questions as we humanly can. But without further ado, let's have some introductions happen. Let's first go with the chair of the department, Dr. Shahabi.
Hi everyone, I'm Cyrus Shahabi. I'm a professor of computer science and currently the chair of the department, as you heard. And what else I should say? I've been at USC for a very long time, and my research background, if you're interested, is data science and AI.
Thank you, Dr. Shahabi. Let's go to Dr. Raghavachari.
Hi, everybody. So I'm Sati Raghavachari, and I'm a newly minted associate professor in computer science.
Congratulations.
And, thank you. So I've been teaching at USC since about 2004, and I teach 3 types of courses. One is about computer graphics animation, and then also courses about data. And the third would be introductory computer science, programming, just basically the fundamentals of the field and so forth.
Fantastic, thank you. And Dr. Halfond.
Hello, my name is William Halfond, and I'm an associate professor in computer science, also the associate chair for undergraduate affairs and teaching faculty affairs. And my areas of interest are software engineering. So many of you will encounter me in 310 in your junior year. And then I also teach graduate level courses on software testing and program analysis.
Thank you so much. And last but not least, Dr. Goodney.
Hi, I'm Andrew Goodney. I'm a senior lecturer in the department. I teach predominantly the intro classes, but I also teach a upper division computer systems class as well. Generally, my research has been in computer networking.
All right, thank you once again. And once again, my name is Paul, Director of Undergraduate Admission. I'll be moderating today's discussion. And thank you again for joining us. Once again, please hold your questions for the time being. I will allow questions toward the latter half of our session, and we'll get to it toward the end, okay? But what we want to do today is get to know more about the department. And as I said, hold your questions. Abby, you weren't listening. You posted a question. Abby, we're deducting 10 points from your application right off the bat, okay? So anyone asking more questions, we're just cutting points from your application right off the bat. So we're keeping track right away as a heads up. I'm kidding, by the way. We're not going to do that, but I am keeping track. Let's talk about computer science. Computer science, it's a discipline. It is a lot of different undergraduate degree programs, a lot of areas of study between that. It is broad, it is diverse. Dr. Shahabi, could you start us off and let us know, kind of a simple question, but a difficult one to answer. What the heck is computer science?
Yeah, that is a difficult question. So, and I thought Andrew was going to answer that, but sure.
Oh, I'm so sorry. I forgot.
That's okay. So computer science, I guess, is the field of, first of all, learning about the information technology and computer in general. And that includes both the computer software and the hardware. But recently, it kind of become broader as computers are being used in so many applications. So it's also getting, I guess, general education and literacy in data and computation. Given the important role that data have these days in so many applications, is basically becoming kind of its own entity as well. So computation and data literacy, I would say, if I want to quickly summarize it.
That's great. Do we have any other ideas? People who want to jump in and add to that?
Yeah, I'll just add to what Cyrus said. So it's almost like a fourth form of literacy that we need for people to have in the world. Computer science is one of those. So the first three are reading, writing, and arithmetic, the 3 R's. But now the fourth R would be reasoning. So if you want to practically do anything in the world these days, it involves computation one way or the other, using software, data, like Cyrus mentioned. So we think it's as fundamental as like reading and writing, really.
Okay. And given that it is kind of this necessary fourth literacy, why should someone choose to pursue it as an undergraduate degree program rather than just brush up on some knowledge related to it? Andy, I'm going to have you jump in on this one.
It teaches you how to, sorry, somebody's making an appearance here. She was getting in the way a minute ago. So that's why I kept looking down. She was like, she's getting into stuff in my office. And so she's going to sit with me for a while until I have a chance to yell at the kids and have them come pick her up. But computer science as a discipline teaches you a lot about, I guess, logical thinking and problem solving, how to understand information, how to process that information. And you can really think of a computer science undergraduate degree as setting you up for jobs in fields as diverse as medicine, as finance, nearly any type of research that's done these days across all disciplines requires help from computer scientists to understand the data that we're generating. There's all these stats online about the amount of information that's generated every day, just from the fact that the internet and everything we do is tracked and logged. Being able to exist in a world where there's that much information that needs understanding, computer science is the way to get that understanding.
Fantastic. Now, the other thing I want to discuss before we kind of get into the curriculum, and this is really for anyone, what do you think the difference is between someone studying, let's say, a computer programming course in high school or an online course in programming versus actually going into a computer science degree program? Sometimes students we have usually two types of prospective students. One that feel like they're so prepared, they may think that there's nothing they can learn in a computer science degree. And then there's other students in our audience that are worried because they have no experience in programming. So how do we address both of these ideas?
Maybe I'll address how we handle the programming side of that. We have a series of courses that teach programming, and we have different ways into that series of courses. And so we can, assess your skill set and your background, and then find the right classes for you to take so that the programming skills you're learning are appropriate to your background. But then at the end of it, after everybody has done the course sequence, we kind of like to think you're all at one, very high level in programming, regardless of where you came from with your background. You can start with nothing. You could start with, 5s on the computer science AP. And, we will, our goal is to make sure everybody who comes into the computer science program leaves this intro sequence with a really solid understanding of how to program, because in the end, I always like to say in my classes that programming is not computer science and computer science is not programming, but it is a skill we use every day as computer scientists. And we make sure everybody has those skills when they're ready to move on to these other courses that are more mathematical based that maybe some of the other faculty could address, which is the other side of your coin, or your other side of your question, which is, even if you're a programmer already, what are you going to learn when you come to study computer science? And Cyrus and GJ, I'm sure, could help us out there.
Well, to add on to that, recently we introduced a new intro sequence because in fact about 30 to 40% of the undergraduates who come in don't have a strong computer science background or may not have taken computer science classes in high school. And so we've recently introduced a CSci 102, which actually is our gateway class into computer science. And undergraduates, they may test, or incoming students can test out of this over the summer before they enroll. But by default, everybody goes into 102, covers a lot of the basic programming skills, brings everybody up to speed so they can take on the really tough courses like 103 and 104, which are really the core programming skills. So we make sure everybody can hit that basic level of common proficiency before we start the core classes.
I also want to add that, I mean, one part of the question that whether just learning programming is enough to become a computer scientist. And I mean, the answer obviously is no. And I think it depends if you want to learn things at the surface or you want to get deep and understand the foundation and what's underlying the surface. And programming, you can think of it as a tool. So for example, even the first programming course, you can teach it differently. You can teach it by just focusing on the syntax and semantics of programming, or you can teach it by teaching someone to understand how the algorithm work and how they should have this algorithmic thinking of approaching a problem. And I think that's the real difference of just learning programming versus learning computer science. I think you can see this repeated throughout the 4 years of the undergrad, where you learn about, for example, how the software on computers work, like operating systems or compilers. And these are these foundations that would help you later on to solve challenging problems rather than just having a tool that you don't know how exactly the best way to use.
That's great. Sometimes I draw comparisons to, you know, just because you had a wrench or maybe you fixed one part of your car before, that doesn't make you a mechanical engineer. So having a few programming courses under your belt doesn't make you a computer scientist or a computer engineer.
Languages come and go, by the way, you know. So right now, C++, Java, it's all the rage, Python. But
yeah,
now maybe they'll be gone. So if you only know programming, then you're stuck with, you know, having to like migrate to some other language, although you don't have any basics at all also. So in computer science, we teach you behind the scenes about what actually these tools are used for, like Cyrus was mentioning, programming networks.
That's fantastic, because one of the questions I have, because we get this a lot from our students, is what language do you teach in? And it's not about teaching in languages, that they come and go. I often blow some students' mind when I say, you know, most of your faculty have never taken a class in the language they're teaching you. Because it was different at that time. You know, you guys we're all back in the cave dwelling days, right? We were doing that on the wall, right? Back in the day.
Zeros and ones. Switches.
Yep. And to address the other side, we have a whole suite of classes that are essentially math classes. And, you know, we have a whole series of classes where you will not write one single line of code, but yet you can take this class about how algorithms work from our Turing Award winner, if he's teaching that semester. So, you know, we really, computer science, like you said at the beginning, Paul, is a hugely broad discipline, and an undergraduate degree is going to touch on all of those broad pieces of it, and then give you what you need to specialize if you're going to go to grad school or industry. A degree like you get from USC is broad enough that you can do anything, you know, with that degree when you're done.
So that's a great segue to my next question. I'm gonna combine questions, and I'm sorry, I'm probably gonna complicate this a little bit, but I want to talk about the undergraduate degree programs in computer science. We have computer science business administration, computer science games, and computer engineering and computer science, which is jointly administered from the electrical and computer engineering department. And there's a great understanding of the spectrum of hardware versus software at the top level. But can we talk a little bit more about what these degrees do, what the curriculum might be like, what the differences are? And then I want to add something at the end of this question, which is buzzwords and hot topics, right? And this is already happening in the chats a little bit, which is, you know, I want to study AI. How do I do that? I want to study machine learning. How do I do that? I want to study data science. How do I do that? I want to study robotics. How do I do? I want a degree in AI, and they don't understand that's not necessarily at the undergraduate level. So look, that again, very broad question. You know, feel free to jump in. GJ, do you want to kick us off here?
Sure. I'll start with just kind of talking about the 4 different kinds of computer science degrees we have. You know, a lot can be learned about these degrees by knowing who they're in collaboration with. So for example, the computer science degree is within our department. So you're just required to take CSci classes plus, you know, other kinds of math and foundational classes, but it's mainly focused on taking a lot of the core computer science classes that are offered by the CS faculty. CS, as you mentioned, is a joint degree with the electrical and computer engineering department. So it tries to do a little bit more of a mix of the electrical engineering style courses, the computer engineering style courses, plus the computer science courses. And so students are getting a little bit of both of those 2 sides. when you talk about the CSBA, the business CS and the business administration degree, it's a co-degree with the Marshall School of Business. So students' requirements are involved. They take core CS classes, and they're also taking core business classes. And then finally, when you get to the CS Games program with the cinema school, so you have students who are taking that core set of CS classes, but also taking classes in game development or the cinematic aspects of modern game development. So you kind of get a sense, just even just by who we partner with for these different degrees, what the focus is and how it's either split or centered on one particular group of courses.
Any other thoughts?
Yeah, I guess maybe about these other subfields of computer science, if I may, like AI or data science. I would say at the undergrad level, I think there is enough time to build a strong foundation. And we have courses in robotics and AI and so on, but I don't think we should go as far as creating a whole degree, undergrad degree in AI or an undergrad degree in data science. I mean, data science is a little different because of depending how we define it, but if you define it as a subset of CS, I don't see a need yet, at least, to define this as a new degree program. But of course, once you enter the graduate degree, for example, a master degree, then there are specialized master degree in AI, master degree in data science that we offer at the department. So that's, I guess, the answer to whether there should be a degree at the undergrad level, like CS in AI.
Absolutely. I think the undergraduate degrees all have opportunities to touch on those areas, and people will have them as part of their life. Research areas are involved in this, and that's definitely an advanced discipline as you kind of build on top of your computer science degree and figure out where you're going to be applying that, because you need to have a lot of that understanding. But let's talk a little bit about research then. Can you, maybe Dr. Raghavachari, can you tell us a little bit more about some research in the computer science department and where we see computer science going?
Yeah, I personally am part of the teaching faculty track, so I won't speak heavily about the kind of research that we do, but I can speak in broad terms and I'll let others fill in the blanks. Yeah, we do a little bit of basically every kind of application that there is in computer science. For example, AI, machine learning. There's a whole bunch of stellar people that do good work there, and software engineering. We do research in it as well, and same with computer graphics and even operating systems compilers. So anything that can be used as anything that computer science can be applied to, there's definitely a research track that is going on in our department.
Maybe I can just organize it what Sati just mentioned. So there are, within the department, we have 4 main areas right now. Area 1 is basically, broadly you can call it AI, but it includes artificial intelligence, machine learning, research in privacy, trust, security. So all of that is under the AI ML area. The second area is, again, broadly, you can think of it as systems. That would include databases, networking, software engineering, anything that has to do with the actual computer systems in a broad term. The third one is called theory, which is basically the computation theory and all the foundations underlying the computer science. And the fourth area is basically a combination of robotics, computer vision, graphics, and human-computer interfaces. So as you can see within these 4 areas, we pretty much cover, I would say, almost all ongoing research in the field.
Great. Now, there are sometimes concerns from students about having to be 100% committed to one of these fields, or knowing that they want to do one area versus another. And I think everyone should know that flexibility is built into our program. And when it comes to the admission process, I put a note in the chat that if you would like to attend an admission event where we talk more specifically about these, please go to that link so we can get into it a little bit more. But realize that putting down something on your application, you get admitted to that. You're also admitted to all the rest of our programs in the Viterbi school. So you have flexibility. You don't need to decide right now. Just pick something that sounds cool. More specifically, there are a lot of questions that have already come in, even though I told people not to ask questions, but I'm just giving up now. That said, they're basically wondering, like, when do I have to choose? Or what's the best choice for me if I want to do this very specific thing at the end of the road? And I know there isn't an answer to that question, but how would you talk to someone when they say, tell me what I'm supposed to major in?
At least within the computer science major, very deliberately structured the intro sequence for all 4 of the computer science majors to have basically the same core. So at least within computer science, you can proceed mostly through the first year and a half, sometimes 2 years, without having to commit to a specific group, because the core classes like 103, 104, 170, 201 are all required across the board. So that allows people to keep their options open a little bit longer if they're still trying to figure that out.
And Paul was trying to speak to this, but if you go and look at the general undergraduate engineering curriculum, the Viterbi school is essentially designed to let you change majors within Viterbi without too much disruption to your course schedule. It's one of the reasons why computer science students take Calc 3. Besides being a good, just a good discipline to have good foundational knowledge in, we want students to be able to come to Viterbi. You might have something in mind, but we've all had students who get one semester in and realize that what they're doing is not what they want to do. They want to do this other engineering discipline. And in some ways, I almost think we should let the Viterbi students not even declare. Just come to Viterbi, take your foundational classes, learn about engineering, and then specialize a little bit farther into the program.
Yeah. I definitely agree. I don't think it's good to maybe commit too early, so to speak. Instead, take the time, explore what's all out there, and then who knows what you might like or what you might not like. So don't come in with heavy expectations about what to do. It's too early for that, honestly. So just find out what's out there and then pick. You have plenty of time.
And to clarify, when you do apply, when you put something down in your application, you're not declaring, you're not locking yourself in. You're just telling us what you think sounds cool to you at the time, and recognize that I think in summary to these answers, computer science and engineering as a whole is what I would refer to as an experiential process. It's something that you have to kind of go through and you have to absorb, you have to be a part of, you have to decide whether you like it or whether you don't like it or whether it's speaking to you. And that's also, I think, important to understand when understanding kind of these specializations inside the discipline, what you think you're going to like, computer science business, or how you start to specialize and shape your degree in computer science itself. Do you like, when you're looking at the back end of stuff, you're looking at the front end of stuff, are you much more of a database person? Like, these types of elements all come into play. And I think that I want to pivot this question more towards how do we structure the learning opportunities in the school? What is the teaching process like? Can we speak a little bit more about collaboration and talk about our focus on group projects a little bit more? Maybe give some examples of some projects that our students are working on.
Sure, I could start by talking about probably one of the biggest group-oriented classes is software engineering. As you know, software engineering, it's a lot more than just programming. It's how you develop software, large-scale industrial-level software. And this is a group process. The days of one person by themselves designing these massive systems is long past. And so what we really focus on in 310 is what are the mechanisms, what are the processes, what are the tools that the students need to learn to be able to work in a group and to be successful in building and testing these very large scale systems. So we consider that experience of going through the group work, the mimicking the kinds of practices that are done in industry as part of a really important part of teaching students how to become more than just programmers, to become software engineers.
My classes don't have group projects, so. But that's just because they're the intro classes. But
okay,
I know Sati's classes do often.
In my graphics courses, definitely, some of the homeworks are group projects. So students work in groups of 3 or 4. And it's a very interesting experience, because everybody takes on a role and then there's a final presentation. It's a lot of fun and students take a lot of pride in contributing their part and watching this whole thing come together. It teaches you real world skills because, like GJ mentioned, nobody in the real world writes like any large piece of code by themselves. You definitely pretty much have to work in a project. So it's nice to develop those skills while you're still in school.
And we have these capstone projects towards the end of your program, towards year 4, where you basically take whatever you learned over 3-4 years and combine it in groups into an actual something that comes as close as possible to a software product, I would say.
And often those capstone projects come from industry contacts. That's my understanding.
Good point. I think in the game field, that's exactly what happens. If you're in the game track, some of the game projects the students work on, they're almost industry level games. So companies like Microsoft, Electronic Arts, Blizzard, they actually come and attend those game demos and sometimes even make offers to students. Those projects are that good. So it depends on like the track that you're in.
Actually, the game one is interesting example because the capstone game also includes students from cinema school. Because developing a game is more than just the engineering or the programming aspects of it. It's kind of like a production, like a movie. So you need the producer mindset as well as the artistic mindset to be combined with the technology computer science aspect. And that's what the capstone there emphasizes on.
So let's talk a little bit more about where this is going. You mentioned industry. Where do our students end up going after their undergraduate degree?
Google.
Just all Google. Just all Google. We know we go more places than that. What are some of the places that they go to, and what are the types of jobs that our students are getting?
I think one big category is the main kind of computer science companies, such as Google, Facebook, Amazon, Microsoft. So that's the obvious one. There are another category that I've seen. These are financial companies that I see. They also recruit computer science graduates, like companies like JP Morgan, and that they do some sort of financial analysis. And then another group is in general, any industry that require kind of information technology or data science. So the main company's business is not computer science, but they do need that expertise. So these are different sectors. For example, I've seen oil companies like Chevron and Exxon and so on. They hire computer science folks in medical, like hospitals and so on. They hire computer science folks. So these days, actually, there is no shortage of companies who are interested in hiring computer science graduates.
We also get a lot here in Southern California of defense industry, since that's a big industry here in Southern California. Your defense industry companies also recruit heavily at USC.
Yeah, Lockheed Martin, Northrop Grumman, Raytheon.
Yeah.
Yes,
And the game companies also, I forgot to mention. I mean, LA is famous for the game companies because it's kind of the intersection of art coming from Hollywood side and technology. So Blizzard, for example, is one of the companies hiring a lot of our graduates.
One last question, then we're going to go to our audience with some of their questions. But we put something in our poll where we had like, what kind of fun question would you like our faculty to answer? We're going to hit this one up now. So if you were not a faculty member, what do you think you'd be doing professionally?
Oh.
Is this in light of COVID or not?
No, you answer however you like, man.
If I weren't faculty, I'd be a baker.
A baker?
Yeah, and maybe that's related to COVID. I don't know, but that seems really like a relaxing. Get up early, get your work done. You sell baked goods, and you're done for the day. I think it would be good.
I'll follow up. What is your signature item on your menu?
My signature. If I had my signature dish or whatever.
Yeah.
We are going to go with some sort of cupcake, maybe.
Cool.
Okay. Other ideas for alternate professions in an alternate universe?
So I wanted to be a movie director. I actually told my father that I want to be a movie director, and I grew up in a country and in a culture that you either become an engineer or a doctor.
Yeah.
So when I brought up the movie director, my answer was that, oh, sure, you can do that, but what you want to do for actually studying? So I said, okay, yeah, fine, computer.
And what kind of directors are you inspired by? What's some of your favorites?
I have actually a couple like Scorsese. I don't know if you know him. Yep. I mean, that's
personally, I don't know him, but I'm aware of it.
Right, and Woody Allen. I know he's not the best character right now, but I like his movies very much.
Okay, DJ Sati.
I don't really have a glamorous one. Honestly, computers have been my hobby since I was a little kid. I was like 10. I was teaching myself to do assembly language, and so I think really, when I get chances to do stuff that's not work, I'm programming. So I would definitely choose to be a CS programmer in some major company.
Great.
Cool. I would study babies all my life. Very young babies, how they learn, how they explore the world, how they acquire concepts. I'm just fascinated by that. So
Wow.
Child development psychologist, that's what I would be.
Wow.
There you go.
Well, you just beat everybody with that answer.
Yeah, I know. That's
Oh, babies are fun.
That's great. I love that.
But so is computers, so is baking and being a movie director.
All right. So we're going to dive into questions, and I've seen a lot of questions, and someone just asked in the YouTube chat, are we going to answer all of them? No. It's impossible, guys. And I don't know if you've seen how many questions you've been asking, but no. We got an hour. We're going to get to as many of these as we can. A lot of them are repetitive, but I will do our best to handle all of these. And if you have further questions, you can email us at vadmit@usc.edu. You can go to one of our admission info sessions, which we put a link. We'll put another link in there for everybody. Viterbi.live/events. You can attend one of those sessions where we get to all the questions. We have more time to discuss. We're going to do whatever we can right now to handle these questions related to the faculty. First thing, there's a lot of questions related to CSBA. And so I want to make sure that we handle that real quickly and understand the differences. And I want to give my take on this, and then you all jump in and correct me on this one, or add or take away. A lot of you might be interested in CSBA because you think it's this golden child of a degree program. Like, oh, that is the perfect degree program. It combines computer science and business. I will become a CEO, master of the universe with that degree program. And I just stop you right there and say that's false. That's not true. And where people tell you like, oh, you should study computer science and business is usually because they're saying you should get some sort of degree in computer science and likely get a master's degree in business administration. This is not a replacement for that. This is a program that takes the computer science software degree program. It takes away some classes. So you might want to analyze the actual course load and understand the differences between computer science as the Bachelor of Science degree and the computer science business degree to fit in courses in undergraduate courses from the Marshall School of Business. Sometimes when I talk to those students, they refer to themselves as on Mondays and Wednesdays, I'm a business student. On Tuesdays and Thursdays, I'm a computer science student. So kind of this nice blend. It is one degree. It is not a double major. It is a hybrid degree program, and you get a single degree called Bachelor of Science, Computer Science, Business Administration. It's that if you have an equal interest in undergraduate courses in business, accounting, finance, organizational behavior, marketing, these types of intro-level classes that you want to take along with a computer science degree, that's a nice bridge degree program, I think. But it's not for everybody. But look at the courses because you do lose some courses in programming. To add complements to that, computer science games is the software degree. We're adding game elements and cinema courses and graphics courses into that at the same time, kind of specializes your degree related to game development. Computer science as a whole has lots of flexibility and you can specialize as you go. And then computer engineering, computer science is a balance, kind of a 50-50 split between hardware and software. So jointly administered by electrical and computer engineering and computer science. So you are taking ECE courses and computer science courses all along through it. I said CSBA, but I wanted to give all of them out real quick. Any corrections on those guys? I did as fast as I could.
I would just add that for CSBA, I think the value that students are finding in it is that if you are thinking of going to one of those companies like Cyrus mentioned, JP Morgan, the big banks, the research or the financial institutions, CSBA gives you enough background in the business side that you're not trying to play catch up with the sort of the language and the operations that you find inside of the business world. So you'll have the same background as your other new employees that came from a business degree. You'll understand the business side of it and then have your programming skills on top of it. So I think it just gives you a better foundation. If you really want to go into that part of industry, it gives you the background you need to succeed out the door. Whereas if you tried to do one of those jobs with a straight computer science degree, it's likely you would still excel, but you're going to do a little more self-study to learn, like, what is that acronym? What's EBITDA? What's this? What's that? What do all those business kind of things mean? You're going to get that with the CSBA program.
Thank you. For another question, does the computer science department lean towards theory or practical applications, or is it a mix between the two?
The intro sequence is definitely, and by design, split. So some of the core courses that you take in programming are things like 103 and 104 and then 201. almost marching in parallel with those is 170 and 270, which are a little bit more of the theoretical or the math, the computer math oriented courses. And even 104, where we say it's programming oriented, you're learning how to develop and do different kinds of abstract computational machines and data structures.
What do you hope students in the Viterbi School will take away from their 4 years at USC?
Problem-solving confidence.
Problem-solving confidence. Yeah. Engineering is all about problem solving. Doesn't matter what degree you get. It's, can you be given a problem, figure out the steps that are necessary to solve it, come up with a plan, implement it. If it didn't go right, figure out why, circle back and try again.
Yeah, we like to think that we teach you guys to think, not just give you some facts and have you graduate, but more like the thinking process is something that will stay with you your whole life. So we like to, think that that's what we prepare students for.
Thank you for that. The next question is all related to cybersecurity and computer security. What are the options for students that are interested in pursuing a profession in these fields?
Yeah, again, so the undergrad program, again, we don't have a specialization necessarily in cybersecurity, but we do have a couple of courses related to that. I think 430 comes to my mind. It's just a technical elective, and it does teach network security. So what was the main question? Was it whether
Well, someone wants to go into cybersecurity.
Yeah, I mean, again, I think that definitely you need the foundation first. I mean, in order to protect the computers, you need to learn how they work. And then on top of that, then of course, you need to learn about the security aspects. So again, computer science general, I think would be the first step.
And I'll add on to that. Students regularly going into that field are majoring in computer science, and then they pursue a minor in cybersecurity. We have 2 different minors in cybersecurity, one in forensics and one in overall security itself. And that's a nice complement because it helps you understand the actual computer science, the problem solving aspect of it, but then the actual real life, what does it mean to actually, either go after these crimes or to prevent them. And so there's 2 different elements to that as well. Let's talk a little bit about the future. There are numbers of questions that weren't really phrased this way, but this is the overall consensus of this, which is, where do we see computer science either as a discipline or as a profession going? I'll give you a slightly different version of that question, which is, what are we excited about in the future of computer science, or what changes will be happening that maybe people aren't aware of?
I can start with the I guess one study that national academies did, and that was a couple of years back actually. So if you remember, computer science did become actually very trendy several years ago during the 2008 kind of time frame. And that was when basically the IT companies and the Silicon Valley started, and they were doing very well. And there were a lot of interest in computer science. There was enrollment increased, but then it went down again. And the National Academies did a study to basically see whether the current interest that we are seeing in enrollment in computer science, is it the same thing? And it's going to go up and down again. And actually, the answer, the result of the study was not. This is not the case. And so far, we for the past many years, we haven't seen the excitement and the enrollment going down. And I think the reason for that, as we kind of started with this, is that it's not just the field itself, but the fact that all the other fields are now kind of relying on computer science and using it. It's basically anything you can think of, from even law, for example, or journalism and communication, whatever field you can think of, they are in need of computation and data literacy. So because of that, I don't think there is going to be anytime soon the enrollment and the excitement about the field goes down. And if you think about the major companies that have societal impact these days, they might look like a non-computer science company, like for example, Uber and Lyft, for example. They might look like a transportation company, but they are not. They're really computer science company. Or if you think of a company like Amazon, you might think that they are in warehousing and selling and so on. They are really just computer science companies. So there are a lot of these companies that on the surface that they may look like a logistics company or something else, but in the background, they're really just computer science. So it's an exciting field. It's an exciting time to be a computer scientist. I don't want to talk too much, but I have some ideas of the future, but I want to let others also to chime in.
My feeling is that there is some reckoning coming with the combination of AI, machine learning, and information privacy, because every day we generate tons of information about ourselves. Every day we buy a new gadget that we put on our wrist that knows where we are, it knows how healthy we are, it knows what we're doing. And just the fact that we have that much information out there about each of us as an individual, I don't think is being addressed very well. And I think there's going to be a lot of work in the coming decades to deal with the fact that we live in a very dense information age, and that allows us to have the fantastic lifestyle that we do. But it's also something that needs some consideration about what all of that data means to society, who should make money off of it, where should it go, who should control it. It's a new age as far as information goes. And I think there's a lot of exciting work to be done in that area.
And ethics as well, because with AI, there's so much deployment going on, right? And so, for example, autonomous weapons. So those are like pretty scary when just to think about that thought. But there are people already doing it. So there's no ethical framework, for example, to basically harness all that and put it in a proper framework. So in addition to actual core computer science, there's also going to be extra areas that surround computer science that need to be developed. So it's also a pretty exciting field. Andrew brought up machine learning. I also think that machine learning is actually getting into other computer science fields as well. So that's actually pretty exciting. For example, in computer graphics, whether you develop games or even make a 3D model of something, you would do it the traditional old-fashioned way from scratch. But now it turns out that we can actually bring in machine learning to make those things faster as well. In other words, Hollywood, movie making and game industry, animation, all that is also being changed by machine learning. So it's really fascinating to see how these fields can start to merge with each other. That's also, I think, a little part of the future.
There are a number of questions related to, can I study computer science and maybe minor in something else or pursue other degree programs at USC? And I'll answer quickly, yes, you could do whatever you want. It always comes down to how much work do you want to do and how long do you want to be there? And so I saw one student say, so can I major in all 4 areas of computer science? Sorry, dude, you ain't gonna do that. I'll just tell you that right now. And it's just ain't gonna work that way. And you wouldn't really get a lot out of that. There's a lot of overlap between these areas. So when you think about your ideas, what you want to do in the future and what your passions are, your interests are, recognize that you can combine them in a number of different ways at USC. Let's start first with your degree program as an anchor. And let's understand what it is that you want to do as those areas that we discussed in the Bachelor's of Science and Computer Science. And if you have other interests at USC, there's no better place to do that, whether that's dance or film or cinema or cognitive science, the idea of psychology, the idea of political science, art, it's all at USC. And students in computer science are regularly taking coursework outside of that. You could be a little more advanced, take a sequence of courses that would be a minor. If you want to pursue a second degree on top of your computer science degree, you can do that, but you should plan that would likely be a 5-year program. And that is adding more work onto your program. And if you want to stay at USC and get multiple bachelor's degrees, multiple minors, of course you can, and we will gladly accept tuition checks from you for as long as you want to be enrolled. But I have a feeling you have other ideas of what you want to do, and you'll make those decisions as you go based on your interests, your passions, and more specifically, your return on investment of time and energy. What sounds interesting to you? But you will be doing all those things you want to do. It's a question of depth and rigor, and I think that's what's important to understand. Andy, you look like you're wanting to jump in.
No, I was just saying, you've said it in some of our interviews before. I think you've said it really well. You say something along the lines of nothing's written in stone when you come to USC, and there's nothing in your way. So if you want to do something, if you have an idea, can I do X, Y, Z? You go to Paul and his staff and you ask. Or you go to your department advisor or the Viterbi advisor, and you ask and you come up with a plan and you can make it happen. No one's going to say, no, you shouldn't do that. They might ask some pointed questions about why you want to do it and what you're going to get out of it. But it's possible to do nearly anything you want given the resources across the entire university.
I have never said that. However, I like it, and I'm going to start saying it. And I'm going to claim that I've always said it from here on out. So hopefully no one's listening right now, but I like that. There's also been questions about internships, and I think that we talked about career placement and this idea of where students are going, and we put some links into the chat here. But that's all internships as well. All the companies we talked about, students are interning at those companies. That's how they get the experience. Students are interning at Facebook as early as the summer after their first year. They're interning at Google, at Amazon, at all these, quote unquote computer companies. But as we talked about before, computer scientists are in demand for internships and full-time placements all throughout their undergraduate career. And some people ask, do I have to get a graduate degree? The majority of our students are going straight into industry with their undergraduate degree, and they're being paid well. The average salary is somewhere in the 80s. 80s, I think it's $85,000 a year on our last survey of graduates. And that was 24%, 25% higher than the national average, just to give you a heads up of what the stats that of people coming out of our department. That doesn't mean that's guaranteed for you, but that's just let you know that our students are doing quite well. They're very prepared, and they have lots of options, and they're prepared for those choices. The other thing I want to mention real quick is we've gotten some questions about admission to master's degree programs. This is an undergraduate only event. If you have questions, you should go to the graduate admission, Viterbi gradadmission.usc.edu, and you can learn more about them. But this is specifically for our undergraduate programs. As we start to wrap up a little bit more, I should have had another question ready to go. Here it is. Can you talk about quantum computing and how does that, first of all, what is the field like these days, and how does that work its way into the curriculum, if at all?
I answered the easy part. So it's not part of the curriculum, at least in undergrad. Actually, even honestly, even in our PhD program, I'm not aware of any of our faculty working in quantum computing. I know there are research faculty at ISI, Information Sciences Institute, and Electrical Engineering Department that are working on quantum computing. Now, what is quantum computing? I don't know if I'm the right person to explain it, but I can explain it the way I understand it, which is basically the current computers is based on the Turing machine, and I don't know if that explanation is even understandable, but basically the quantum computing allow you to do things in kind of a large parallel way. So it basically solve problems that's going to take a long time to solve on traditional computers.
Next question. With COVID-19 affecting everyone across the country and all the things that have happened over the last 6 or so months, how have we responded to that, and what is the educational experience like today in the Viterbi School and in your coursework?
We've had this thing called the Distance Education Network. We call it DAN at USC for almost like 40 years. So we're one of the pioneers in the whole country for distance education. So back then it was all a video link between us and JPL and some defense companies in Los Angeles. So we have in the recent times completely capitalized on it, and we're still like #1 in the country over and over every year in distance education. So what that means is we've got the infrastructure, the experience, the tools, everything to deliver a pretty good experience. So in a way, the COVID-19 situation last spring hardly changed how things were done for some of us, meaning like one of my classes, for example, was pretty much half streamed to like students all across the country. And so I didn't have to change much at all, just kept doing what I did, except all of the 100% of the students became online. That's about it. So I would say we actually have a pretty good, like I said, experience, for us and the students in how we deliver instruction. So I think, students do appreciate what we do.
Right. I mean, I can also add to that what Sadi mentioned. So one of the, as we get back to normal, I think there's going to be this intermediate period where we're not going to be fully online and we're not going to be fully in person. We're going to be kind of this middle hybrid that some folks going to be online and some folks going to be in person. And teaching classes like that is very difficult if you're using technologies like Zoom, for example, and so on, because some of your students going to be in person and some of them online. But our distance education network is designed actually for that scenario. So the classroom looks like a studio, so it includes all the students. The students can participate in person, and at the same time, the remote students can have access. So I think the then or distance education network become even more important as we get to this hopefully shorter intermediate time where we need to support hybrid classes.
One of our last questions as we start to wrap up here, there's a number of these, and I'm going to paraphrase them all, so I apologize, it's not verbatim for those of you that have asked this question, but what makes a successful student at USC in computer science, or what do you think is one of the most valuable traits to have as you go through our program?
Be passionate. Understand computer science because it is magic. It is pure fun. Don't do it just because you're going to get a great job at the end, that you want to learn programming. That's not what it's about at all. It is as close as you can come to magic. So if you can appreciate all the amazing ideas behind CS, you really get excited about it, learn it very well for the rest of your life, you'll be all set.
I think I would add, take advantage of all the opportunities. We have tons of people, lots of interesting research going on, getting involved with that and getting to know the professors and who are doing that, the student organizations that are focused and built around computer science related activities. I think just taking advantage of all these things that are also existing outside of just the lectures that you get from professors.
I was going to mention the student activities as well. We have a huge, broad set of student activities that let you focus on entrepreneurship or like a kind of a maker sort of environment, or game jams. Lots of fun things to do as a computer science student, like Sati said. I'll be a little bit more practical. You have to be interested and passionate enough about it to put a lot of time in. It will take time. Sometimes you will spend 8 hours or 10 hours or 100 hours on an assignment. And it has to be something that you're willing to put that time into in order to succeed. But if you do put that time into it, like Sati said, you will understand this discipline that 99% of the people on the planet think is pure magic.
And then my last question, this is the last one that we'll close out with, and hopefully, any one of you can chime in, or all of you can chime in as you like. What do you think sets computer science at the USC Viterbi School of Engineering apart from other top-ranked engineering programs? Of course, they're all good, but what makes us a little more different, a little more unique, a little more interesting, dare I say, a little better? Other than the fact that we have Andy. I mean, Andy obviously just makes it, right? I mean, that's it. But beyond that, that's the obvious one.
All right, Paul, don't make me talk about you freshman year. I'd say it's access to things like the local industries, game industry, Hollywood defense industry, and USC facilities like ISI. We just have some really unique things here in Los Angeles that USC is tied into, and that gives us that little bit of edge over those other programs.
And we have a separate teaching faculty track as well. So I think I need to mention that many big research schools, they take teaching as like a secondary thing that research professors do. It means you might not get the high quality education that you think you might get at the undergrad level. But we have a separate bunch of people that are dedicated only to teaching. So I think even that makes us a pretty good program. Maybe I would say a better program than many top schools for that reason.
I had a problem with my microphone. I don't know if you guys can still hear me.
Gotcha, you're good.
Okay, so I think I have a slide that basically have a list of stuff. So, and some of it I heard already. So the fact that we have a very active research program, both at the master level and PhD level, who actually work with undergrad students. So my lab, for example, we do have undergrad students all the way from freshmen actually. participating in our research. So that I think is unique, the hands-on experience that the students get in these research labs by working on various research projects. The USC Alumni Network, I want to mention that is very important, especially in later on for both internship and jobs, and then the multidisciplinary research, because we are one of the few basically universities that we are kind of having top schools in different areas. For example, our cinema school is #1, our Annenberg School of Communication and Journalism is #2 in nation. We have medical school, we have policy, and we do a lot of multidisciplinary research with these other schools. The entrepreneurial opportunities that USC provide for the students. We have a lot of competitions and programs that the students can apply for, not only get seed funding for starting a company, but also getting in touch with business students to collaborate and so on. I know that we're running out of time, but my list is still going on, but that's pretty much it.
I just had this fantasy of like, we're going to close out and I would let you keep talking and it would like fade to black. Well, I do want to be respectful of our faculty time. They took time out of their day, out of their busy teaching schedules, and really kind of connecting with our prospective students. I truly appreciate it. Dr. Goodney, Dr. Halfon, Dr. Raghavachari, and Dr. Shahabi, the chair of the department. Thank you, thank you, thank you. It's been a long time since I've seen any of you in person. I think the last time I saw any of you was actually on another call like this, where I was sitting in the exact same chair. So it's really good to see you. Thank you to all of our guests that joined us. We had hundreds of people in our webinar. We had another 255 people in the YouTube stream, and we were trying to bounce between those. So I appreciate all of you attending. Again, a lot of the questions relate to admission. So go to viterbi.live/events. And register for one of the admission info sessions. We have first year info sessions and transfer info sessions. There are student live chats that are going on every other Sunday night on various topics. And the application process is all on our website, viterbiadmission.usc.edu. Don't forget to apply by December 1st in order to be considered for merit-based scholarships. And one note that's been talked about a little bit in the chat, we're test optional. So please stop worrying or thinking about an SAT or an ACT for fall 2021. Do not think about it, do not worry about it. There's no advantage to submitting a score. There's no disadvantage to not submitting a score. Just forget about it. I already have. And trust me, it was the easiest thing to do because I never cared about them anyways. Anyways, so thank you again for everybody. I would love to keep you all on to chat real briefly, but once I end it, it's going to say goodbye. So thank you, thank you, thank you. Have a great, great evening. And I wish you all adieu. Bye-bye.